Hi and welcome to video 7 on this series on annuities, and of course this series is from topic 1 unit 4 general mathematics curriculum. We're going to talk a bit more about annuities today, take our examples a bit further and use it to draw some comparisons between a fairly simple case, and we'll even have a quick look at the extension. So we'll do this one example in this video. It'll be a fairly short one. Example. If I can invest, let's say I can afford to invest $600 per month in an annuity, which is the better choice? An annuity at 6.3% per annum compounded monthly, or an annuity at 6.5% per annum compounded yearly, with yearly contributions. Compare each option and make a decision. So what I'm going to do is I'll just add a bit of space here, is in the comparison, I'm going to just have option 1 and option 2. Hopefully I've got enough space there. And I'm going to write down the things that I know in option 1 and option 2. I might even just move this to the side a bit more. There we go. And so in option 1, we are saving. So I have A is equal to 0. So it's one of those situations. And we're going to be using the formula. I'll write it up here. A is equal to M. And that A is kind of like our P again. 1 plus I to the power of N minus 1 over I. And in option 1, M is 600. But in option 2, M is equal to 7,200, which is 12 times 600. Same amount, but depositing yearly. I'll go back up, you can see it's $600 per month. I is equal to 6.3 over 1,200 there. And over here, I is equal to 6.5 over 100 because it's not monthly, it's just yearly. N is equal to, don't know. And we're not given a time period. That's a bit of a problem. And I want to know which one's going to create the most money. So therefore, I want to find A, which is also equal to dunno. I've got a couple of dunnos in there, which is a kind of a problem, but not really, because this is a comparative question. So I don't know for sure, but I suspect that the trend is going to follow. And of course, we know that the shape of these types of distributions, it's going to look like this. $600 starting point. Going to go like that, or perhaps we'll be doing a yearly one, and that will have that $7,200 starting point, but it should still follow, and it might cross over and go like that, or whatever. But we should get that consistent platform. So let's have a play with this using the formulas and see which one comes out just based on a random N, and that can be our first level of comparison. But then we're going to do the extension and take this a bit further. So M600. I is 6.3 over 1,200. I'm going to say N is 10 years. 10 times 12. And so in this case, A is equal to 600 times by 1 plus 6.3 over 1,200 to the power of 120 minus 1 over 6.3 over 1,200. And when I do that calculation, it comes out with 99,945, which is just amazing. But anyway, and that's, I've said 945.01. And I've rounded pretty quickly here, but that has decimal points after it. Over here, 10 years means 10 instead of 120 because we're doing yearly. And so I get A is equal to 7200, 1 plus 6.5 over 100 to the power of 10 minus 1 over 6.5 over 100. And this time I'm going to get equal to 97,159.84. And so there's that comparison for 10 years, and you can see that the monthly is better. And over time that should be the case. So if I wanted to compare this more directly, what I might do is just forget the M and just deal with the multipliers. Now, I've calculated the multipliers here, but for the 10-year rate, the N's a bit of a problem, but it's not too big a problem. So what I could do to take this further, and I won't go the whole way, is let's leave N as 10 years. Now, I'm telling you that we get A is equal to M times, and this is for the monthly one, M times 166.575. I just calculated this thing here. And over here we get A is equal to M times 13.4944. So now they're not very comparable, but what I've done is I've taken this value here. If I divide that by 12, I get a multiplier of 13.88. And that trumps this multiplier. And that's the important thing. So if I divide this by 12, then I have to multiply that by 12, which makes my investments the same. So I'm making a comparative multiplier. Now, what I could do, and what I will do quickly, is I'll look at this, but I'll look at it this time, and I'm on a calculator. I'll look at it this time where I set my N as 1 year instead. And that's going to give me probably the best comparison. So my 1 year calculation gives me for monthly A equals M times 12.3526, but for yearly A equals M times 1. And that makes sense because for yearly that's 1 plus 6.5 over 100 to the power of 1 minus 1 over 6.5 over 100. And of course that cancels with that. Well, the 1 plus that minus 1, they cancel out, and therefore this one cancels to this one. So we get a 1 there, and if I divide this by 12 to get a comparative rate, you'll see that we get something that's approximately 1.29 ... which is better than that 1. So comparatively, even with the 6.3, over a year we're getting a better rate. Now it's hard to compare less than that because this is a year, and so we had to have at least 1 year compounding period, but we did get a better rate here, and we continue to get a better rate over time. So it's telling us the monthly is going to be better in the long run. We could take this into a bit more depth. It's a pretty hard question, but it's just there to open your eyes a little bit, that extension. So there's a comparison. And so I'm going to leave that video there, and all the best.